Hi, welcome to this video on Raspberry Pi and LED Play. In my original idea of having one LED on this side burn and then one on this side, I've taken a slight change. And that is that I will let this side run C++, which is the RPi2 side, and the RPi1 side will be in Python. Last time, if you have watched the video, then you also noticed that this side runs remarkably faster than this side. Also, this LED is not burning, the rest is. So what I need to investigate right now is what is causing the difference in speed, but I also have to find a replacement for this LED, because of course I want all LEDs to function properly. So those are the two focuses of this episode in LED Play. And the first thing to handle is finding another LED. With replacement of a defective LED, and I detected that by using a multimeter, and a small correction on the connection to the band cable. All three LEDs are now properly working. As you can see right here, this is the replacement LED, and unfortunately this one is not as bright as these two, but they are working. And let me show the code. I removed for this new setup commands that have nothing to do anymore with the old code. So this is putting the GPIO output to 1, wait for 2 seconds, set the output to 0, which of course means LED pin, the GPIO pin 7 on and off. This is GPIO pin 12 on and off, using for that GPIO 18. This is the official name and this is the pin number, and that for all three LEDs. So as you can see, everything is set to 2 seconds. So let us now start on the RPi1 side. Yep, I have to run this as root. And let me see if I can show the difference. It is not very clear, I think, but they are not synchronized in any way. So the question is, why is this code, which is actually exactly the same, LED 1, LED 2, LED 3, running faster than this code in C++? In seconds you should not notice anything. The only difference between the algorithms, well, there is no difference in algorithm, but difference in code is this is in C++, which is a compiled code. I recompiled it after removing commands. So basically this should run faster. This is Python, which has to be compiled, not to be compiled, which has to be interpreted each time it runs. So, which is, at least in theory, slower. And then this is the RaspberryPi1, which runs slower than the RaspberryPi2. So those are all elements that indicate that there's something odd going on, and I have to find out why that is, because if I want to continue with the LED play, which with the intention of one LED on one side, then one LED on the other side, and so on and so on, and they run after detecting one another, then with an asynchronous run it won't work at all. But that's what I have to find out next. When comparing the code, it is always nice to wait a bit and then look back at the code, and then I notice that the only sleeping time is between the true and false, and not between the false and true in the Python code. Looking at the C++ code, I see something completely different, because I have in between the true and false 2 seconds, but also between the false and true. So and that is wrong. So when I put this in comments, oops, and I have to cancel this. Yes, then save this one, recompile, restart, and now there's a little difference, as if it is running behind a very little bit, like half a second. And maybe a better view of that is when looked upon it from above. So let's just do that. When looking from the top, you see the upper side running Python and the lower side running C++. And although they look like running a little bit apart, there's something remarkable. This is 1 second, as you can see, or approximately 1 second. However, if you wait long enough, they kind of run the same. So there is a very small change or difference in speed. Let's see if that happens while the camera is running. I do hope so. At least the LEDs are working correctly. This is not the LED play I intend. And it takes a bit longer than expected before they are synchronized again, or look like synchronized. There's still difference in when. But it's coming closer. It's going very close now. Few moments wait, and it looks like they are going at the same time. Almost 3.5 minutes. Anyway, the timing is a little bit off, and I have to find I could find out why. However, the most important thing now is that the circuit is working and that the algorithm is really the same now. So I could start experiment by reading the output of the other board, so that this one is responding to the output of this one, or vice versa. This wire is going here, which is for this LED, so I can start that. And let's do that. So with all LEDs working and the timing almost okay, it is time to do the first step in LED play, and I decide to do this, that I use the input from the RPi2 pin 7 as an input for the LED 7 on the RPi1, hoping that that works. So I have an output, and of course the GPIO4 is an output itself. This is it is pin 7, and it is being wired to pin 11. So all I should do is remove this command here. So if GPIO 11 is high 1, print this and then show that pin 7 on this one is true. And I do hope this works. In order to show that that actually does work, I will comment out these. And for this one, because right now the other LEDs may act confusing. So this is one thing. They will not burn for now, and I of course have to compile this. So let's do just that. Okay. So now only on the RPi2 side. Let me find, that is this LED will burn, and on the other side the other one, let me show that one as well, which is already burning, which is this one. And that should run. And let me comment the other lines out as well to avoid confusion on what is happening. Now the question is, does it start? Well, this one is a while, this one is a while, so it has an unend. Yes, take care of that. And now there is another point. They are both burning. Let me show. So this one is burning, and this one is burning, and that's a nice one. So now I probably should wonder the setting false. I don't see it getting off, and this one is, to be sure, is this one on the RPi1 side, so that should be going off with a sleep of 2 seconds. On the other hand, that's another one. This will solve this. This is more likely to work because I have to say, okay, you should sleep for 2 seconds in the false state. So let's do that. And what is happening then? Not much actually. So then I should probably go here, remove the comments, oops, compile again, run, and see what happens then. See, that is a difference, because now you should be able to see that this one, now you can see it, it's getting on and off, and this is right here. So looking at this point, the question is, why isn't side 1 running? It's from RPi side 2. So this one is getting on and off. This one is signaling the on and off input state. So this one should get off as well. However, it is constantly burning, and that is not the intention, but that is without a doubt a code error. And if I break this now, it is not getting any input anymore. With the simple result that this LED on the RPi2 side is not burning anymore. Which is kind of logical, because I quit it completely. And now it starts working again. So I have to revise the algorithm a bit. But the first thing I think is fine now. And in the next episode I will get on with all the well, maybe not all, but involving more LEDs in the LED play and adjusting some code. For now, thank you for watching. and to be continued. And so far I had to adjust one connection to the band cable on the RPi2 side and replacing a defective LED. But as I said, thanks for watching, and to be continued. Oops, this one.